This is Shelley Physics. We're looking at linear motion practice E number 5. Maria throws an apple vertically upward from a height of 1.3 meters. This is very similar to number 4. Got Maria, and she's tossing an apple upward and should do something like that. That would be its trajectory. So it starts 1.3 meters above the ground with an initial velocity of 4.4 meters per second. I'll go ahead and write the initial y, initial height, 1.3 meters. A, will the apple reach a friend in a treehouse 5.3 meters above the ground? And don't let that distract you. This is asking will it or will it not, but what are you really looking for here? You're looking for how high it's going to go. You're looking for the maximum or the final y value, all right, at the top of its motion. So if the top of its motion is more than 5.3 meters or more, then the apple will have reached the friend. And if it's not that high, then it won't have reached the friend. So this is the target. It's not 5.3, it's what is the final height. And B, if the apple is not caught, how long will the apple be in the air before it hits the ground? So we might also be looking for that total time. Okay, so I'll write the total time in the air. And that one might be a little tricky. So these are our givens. What do we know about our implied values? So we are looking for the maximum height. So what do we know about that maximum height? You might recall that the vertical velocity at the top is 0, and that marks a point. So we have an initial velocity and a final velocity now for reaching the top. So the last thing we need to know is that distance. So how far it goes, how far does it go? Let me pull out the equations. So if we want to know how far, we might look at that second equation. Okay, this one right here, where x is y now because it's a vertical position. So we do know the initial velocity, but we don't know the time yet. We don't know the time that it gets to the top. So let's try this third one here. Do we know the final velocity at the top? Yeah, it's 0. Do we know the initial velocity of the throw? 4.4. And do we know the acceleration? Oh yeah, that's implied. So the acceleration is 9.8 meters per second squared. But let me check a problem solving text here. I added this one in last time. Let's check the list to be sure that the directions are correct. The directions agree. And be sure that all units agree. All right, so let's do that right now. Turn that off. This velocity is positive and it's upward, but the acceleration is negative. It's downward. This is a positive starting position, so that's above the ground, so that's also positive. It's not below the ground, or it's not below a point, so our directions and units agree now. So I'm going to use the third equation, vs squared equals v0 squared plus 2a. I'm going to use again, just like in my starter for practice E number 4, instead of just using an x here, or in this case it would be a y, that x is actually a change in position. Usually the initial position is 0, but here our initial position is 1.3, so this is going to be the final y minus the initial y, and that's how we're going to plug it in. Helps to solve it a lot better. So let's plug in the final velocity at the top is 0. The initial velocity at the bottom is 4.4. Don't forget to square that. Acceleration is negative 9.8. Then we're going to plug in the unknown y final, and y initial is 1.3. So let's see what we can do with this. And it's nice that we're going to have a negative here. You can see it's really important. I'm going to bring out the calculator and cover me up here. So there's a calculator. Now let me move it up a little bit here. Okay. So first we're going to have the 4.4. I'm going to figure that out. 4.4 squared. It's 19.36. So 0 squared is 0 equals 19.36. And 2 times negative 9.8 is negative 19.6. We have a y final minus 1.3. Let's do some algebra here, distribute that. So 0 equals 19.36 minus 19.6 y final, and a negative times a negative is a positive, so this will be a plus 19.6 times 1.3, 25.48. Okay, so there it is. Looks like we can, I'm going to add 19.6y final to both sides. All right, so we end up with 19.6y final equals, and we can now add these two numbers, 25.48 plus 19.36. 44.84. Okay, and that helps us get that final y. We're going to divide that both sides by 19.6, and the final position vertically, if we divide that 44.8 by 19.6, 2.29. Okay, and that is less than, look at that at the bottom, which is less than 5.3 meters. So we should sum this up here. So will the apple reach the ground, or reach the friend? Apple will not reach her friend. Okay. And then we get on to part B. If the apple is not caught, how long will it be in the air? So here, I'd like you to try to finish this one. The solutions will be are posted. You can check those out. But first, I think the easiest way is to find that time up and then the time down, and to calculate them both that way. You do have an initial velocity and a final velocity. So for that first part, I recommend using this equation for that time up, Vf equals V0 plus AT. The initial velocity is the one given there, and the final velocity is 0 at the top. And for the time down, we don't really know the velocity, the final velocity down here, so I would recommend using this one. Okay, this is for the time down, and then you're going to find the total is the sum of both of those. Okay, so sum up the time up and the time down. Now for the second segment, I'll just talk about this a moment to get you started. This is sort of a get you started as well. Let's use y. Let's call down positive on the second segment. Okay, so for the time down, you're starting at some position up here, and you're going to end up way down here. So we now know the final y, how high it is, 2.29 meters. So this is at 2.29 meters, way up there. Okay, so if you start with that, if it's going to fall 2.29 meters, my bad handwriting there, the initial velocity being 0 up at the top, then you should be able to solve for the time down squared. Sorry about that. Now in this case, since down is now positive, this is a positive 9.8 because it's falling a positive 2.29 meters downward. So that should help you solve for that time down. So solve for that time up, use the initial conditions when she tossed it, and then look at that second segment and solve for the time down. Add them together, and that should be your solution.